All right, hey chemists, this is going to be a walkthrough help of you performing the calculations for the NAL lab. By now, you've done day 1 through 3 of this lab. You were able to get the mass of the copper and the mass of the iron and might have a similar data table to something like this. So you had an empty beaker and you got its mass. You have an empty beaker, but now it's not empty anymore. It's got some of that copper chloride solution in there. And then you had the nail from beforehand, got a nail. And then you had a nail after. And then you had your beaker with just copper that had formed in there. And so things that you had to notice or observations. What did the nail look like before and after? What did the solution look like before and after, right? There was a color change. There was something red forming. That was copper that was forming. It looks like the nail changed color too. It went from like black gray to red. The nail decreased in mass. These are things that you have to write down for observations. Then I'm going to walk us through the calculations here together. The first calculation says determine the mass of copper produced, which copper is Cu, and the mass of iron used. I'm going to help color code keep this in track here. If I want to get the mass of the copper that was produced, I need the mass of the beaker and copper, which for me was 126.59, minus the mass of the empty beaker, which for me was 125.45. These are sample calculations, so it is my hope that you use your own data. So for example, if I want to do the math here and I want to get the mass of my copper, I'm going to do mass of beaker and copper, which for me was 126.59 grams, minus the mass of the beaker by itself, 125.45 grams, and in the end I get 1.14 grams of copper. That's my data. Similarly, there's going to be a subtraction with your iron, and so I'm going to say iron is Fe. I'm going to color code that to be like a nice little light green here. I need the mass of the nails before minus the mass of the nails after. So here's the mass of the nails before. I had 2.3 grams. Mass of my nail or nails after, 1.3 grams. I think you see where this is going. It'll be 2.3 grams minus 1.3 grams. That's only 1 gram of Fe. Cool. So for calculation number 1, you need to show both of those subtractions. Then for calculation 2, and this is something that you had just learned this past week, you need to calculate the moles of copper and you need to calculate the moles of iron. Well, we have the mass, and I'm going to highlight that. We have the mass of copper, which is 1.49 grams, and we have the mass of iron, which is 1 gram. Now, if I want to get the moles of iron, I got to do the mass of the copper, if I want to do the moles of the copper, or even the moles of the iron, I need the mass of each divided by the molar mass of each. So for copper, I need the mass of copper divided by the molar mass of copper. And that molar mass, MM, is found on the periodic table to be 63.546. So I'm going to do this math right now. I will have my 1.14 grams of copper. This is my data, but you're going to put yours, and if you want, you could color code this. You're going to put your number there. I'm going to do 1.14 divided by 63.546, and I get 63.546. I get 0.0179 moles approximately of copper. Cool. Still going to highlight this a yellow, so I'm keeping track of that. I'm going to do the same thing for iron. I need the mass of iron, which I just got in the previous step, which is 1 gram of Fe. And I'm going to divide by the molar mass of iron, which if I look on the periodic table, it's 55.845 grams. If I divide these two, would you look at that? It's also 0.0179 moles of Fe. Isn't that nice? Is it a coincidence? Who knows? Then calculation number 3 says determine the, and I'm going to erase this a little bit here. It says determine the ratio of moles of copper, which we just got here, for moles of iron. We talked about ratio in a previous lecture. It's just making a fraction. So we're going to do 0.0179 moles of copper. I'm going to write it as a ratio, as a fraction, dividing 0.0179 moles of Fe. That is my ratio. And then it says express this ratio as an integer. For example, 1.33 can be expressed as 4/3. 0.67 can be expressed as 2/3. We're kind of lucky here. All we're going to do is divide these two numbers and get a number. 0.0179 for my data is 1, which is, I could write that as 1/1, which would be 1 mole of copper for every 1 mole of iron. So it's a 1-to-1 ratio. And done. Also, some good news. You do not need to do the conclusions. This is extra. You could try doing them, but it is not required. This lab was just a good practice in calculating masses, calculating moles, getting mole ratios, just to get us for the unit that we're in. Just a little note here, you may not get 1-to-1. I've seen students do the math and they get like 2.1 when they divide, which is approximately 2-to-1. I've seen students get 2.99, which is approximately 3/1. So if you need help with the fractions, you could always take whatever number you get with your division, here's the division, and make sure you put it over 1. Right, so if I somehow had, if I did my division, and some of you might look like this is just some extra help for you. Let's say instead I had 0.0537 moles of copper, and I divide that by the 0.0179 moles of iron. This number on a calculator is 3, which means there are 3 moles of copper for every 1 mole of iron. That is how you're going to answer the rest of calculation 3. So you are required to make sure that you have data, observations, and you have answered calculations 1 through 3.